Hello, Math 130 students. We are going to pick up on page 19, section 8.5, properties of logs. So here, we're going to first be introduced about these different properties. So then that way, when we are solving for log functions, we have a strategy on how to solve them. So we're going to be looking for patterns. So the product rule comes from them being multiplied. So remember that product I spelled that wrong. There's a T there. There we go. So the product means to multiply. So when we have x and y being multiplied together, it turns into addition where we separate those multiplying factors. So the quotient rule, so we have a quotient, and remember, hopefully you remember that the quotient really represents how to divide. And since we're dividing, we're going to separate that division to x minus. So now the division turns into subtraction. And we also have the power rule. So the exponent gets multiplied out in front. So the power gets multiplied out in front. And then we kind of have like these couple ones down below that don't really have specific names, but they are going to be useful once we see the pattern. So let's look at the examples below. For number 1, it says to evaluate using the basic properties of logs. So we have base 6 to the exponent of log base 6 of 15. So we say that this one is unique in the case that we have the base of both the exponential and the logarithm the same. So same base. Since they are the same base, what ends up happening is it cancels out. So for example, if I'm looking at the different properties, so for this one, I'm going to be looking at this property here. So we have the base, which is the same on both. So what it equals is the 15. Because I have my 15 here, right? So that is what we have for the log. Log base A of x, and that x here is equal to 15. So my answer here is going to be 15. Okay, well I hope that helps. For number 2, we have log base 8 of 8 to the negative 4 power. So now what we're looking at is we have your base, and here the log base 8 of 8. So the base and the of 8 here are exactly the same. So that's going to be looking at this property here. So if that's the case, then your answer here is going to be this negative 4, whatever that n value is. So here my answer is going to be a negative 4. Okay. Now, we've already mentioned natural logarithms, but we can go ahead and mention them again in more detail. So what they are, it's a log with a base of e, which is, that number that we represented. It's similar to pi in the fact that it's never ending, never repeating. And we know that the, pi is somewhat as 3.14, but we know that there's actually more decimals behind that. And the really cool thing about that is that it's never ending, never repeating. So we have, 3.14, but we also have the 1, 5, 9, 2, 6, and it keeps going off, right? So E is very similar, as it's in 2.71828, and it keeps going on and on forever and ever. So we indicate that the natural log, ln, represents that relationship with that letter or with that number e, okay? So it's going to follow the same type of properties as the logs, where we definitely still have the product rule being split into addition, the quotient rule turned into subtraction, the power rule, which is being multiplied, And here the natural log and e, when they're combined together, well, we know they kind of cancel each other out and we're left with the exponent. And it doesn't matter in which order. It doesn't matter if the ln came first or if the e came first. And of course, we always know that the natural log of 1 is equal to 0. You can do that on your calculator and it shows you. So what we want to do is just bring this up on our calculator, right? I want to make sure that you guys are able to use e and really calculate it. So I'm going to press pause so I can get my calculator up. So now that I have my calculator up, we are going to calculate 1, 3, and 5, and then we'll do 2 and 4. So if I have this graphing calculator, I'm going to look up e. So e, notice how it's blue. So it's here and it's blue and it's right above the ln. So I'm going to go to second ln. So now I have my e to the 4.8 power. And I get 121.51.04175. So I'm going to go ahead and enter or write down that problem or that answer. So I wrote down that answer. And notice how it's specifically asking me to round to the 4 decimal places. So if I count to 4, 1, 2, 3, 4. So this is the 4th decimal. So we are going to look at the 5th decimal and figure out how we are going to be rounding. So here it looks like that 1 tells us to leave that 4 alone. So I have 121.5104. And so that is going to be my final answer. Now let's go to number 3. So for number 3, I now have the ln. So I'm going to go to ln. So my natural log of x is equal to negative 0.0674. So this one is actually a little bit more involved than I thought. It's not just as easy as putting it into your calculator. Here you have to remember that natural log and e cancel each other out. So if I'm going to cancel this out, if I have natural log of x is equal to a negative 0.674, then what I would do is I would kind of apply e to both sides. So now the ln and the e cancel. So I'm left with x is equal to e to the negative 0.674. So after I do that one move, now I can bring up my calculator. So this I can say, well, this is e. And I have to the negative 0.674. I'm going to go ahead and copy that down. So I'm going to go to my 4 decimals. So now that 6, since it's bigger than 5, tells me to round up. So rounding to the 4th decimal, I'm going to get that x is equal to 0.5097, since I am rounding to the nearest 4 decimal places. Okay, so now let's take a look at number 5. Now looking at number 5, well, I see this and I have to remember that property. So that property was up above. Let me go ahead and scroll to it. So on page 19, we talked about this property that said that log base b is always equal to 1, okay? And we also have this one, which is really similar. That log base b of 1 is always equal to 0. Okay, so let's think about these two properties and see how it fits into our question that we have. So I copied down what we just saw, that log base b of b is equal to 1, and we also have our other property. And so log base b of 1 is always equal to 0. So it doesn't matter what the base is. If this is equal to a 1 in here, then it's always going to equal to 0. So log base 12 of 1 is always going to equal to 0. Okay, and what this is saying, if you want to know, like, well, how is that true and why is this true? Why is this true? Well, it's true because if we rewrite it in exponential notation, b to the 0 is equal to 1. Anything to the 0 power is always equal to 1. And since it's always equal to 1, then we have that property, log base b of 1 is equal to 0. So the only time, an exponential could ever equal to 1, it's because your exponent was equal to 0. Okay, so now let's do the even numbers. So I'll bring up my calculator and bring it over to the other side. So now I have e being evaluated at a negative 2.6. Okay, so this is the decimal that we're going to get. So I'm going to go ahead and write that down. So I copied down what I saw from my screen, and since we're rounding to 4 decimal places, I'm going to be looking at that 2. So that 7 tells us to round up. So we're going to have 0.0743 as my final answer. For number 4, remember, I have natural log, so the only way to cancel out my natural log is if I were to apply the e property to both sides, so that the natural log and the e cancels, so I have x to the e to the 5.2 power. Now, when I bring up my calculator, I have my e being evaluated at 5.2, and that's the value that I get. So this is the value that I got from my calculator. So we're looking at that 4th digit, which is that 2, and that 4 tells us to leave it alone. So I'm going to have as my final answer that x is equal to 181.2722 as the final answer. And for number 6, what's kind of cool about this problem is that you already have e and natural log together. So they kind of already cancel each other out. And since they cancel each other out, the only thing that's left is a 3. So 3 is going to be your final answer. Now for page 21, number 1, it's asking us to write the logarithm as a difference of logarithms and simplify if possible. Well, you remember from page 19, our properties that we have of logs. And since we have those properties, we're going to apply them. So the natural log of, let's say, x over y is equal to the subtraction of natural log of x minus the natural log of y. Remember, division really just is a repeated amount of division, or of subtraction. So division is repeated subtraction. So it turns into subtraction for our properties of logs. So that means we're going to split this up. So I'm going to have natural log of something minus natural log of something else, because this is the quotient rule that we're going to be using. Since we have division. So now we just take our numerator, and that's going to be the thing that's listed first, so e to the 3rd power. Then we take our denominator, and we plug that into our second pair of parentheses. So then that ends up becoming my final answer. Or actually, that's not my final answer. The reason why is because I still have here a power. So now I have to use the power rule. So that 3 is now going to be put in front, and this is being multiplied by the natural log of e minus ln of 3. And remember that we have that whenever we see natural log and e, they cancel each other out. So we are left with 3 minus the ln of 3 as my final answer. That is as simplified as possible. For number 2, we're going to write this as a sum of logs. The reason that we are going to be adding these together is because we have multiplication. So because we have multiplication, that says to use the product rule. Okay, so we are going to have log of base 5 plus log of base 5. So what we're going to be putting inside of these parentheses is going to be the things that are being multiplied together. So here I have an 8, so that gets put in. And here I have a y, so then that's my y. So that ends up becoming my final answer, log base 5 of 8 plus log base 5 of y. For number 3, we're going to write this as a product because I have the product rule. So that means this exponent gets brought out in front. So I'm going to have log times log base 2 of x. So then that ends up becoming my final answer. And that is the end of section 8.5. If you guys have any questions, please feel free to email me, the Math Success Center, or our embedded tutor. Thank you.